Hello everyone, we're going to talk about the relationships between pressure, temperature, volume, and the number of particles. First, I need to define for you there's two different types of relationships, and then after that we're going to talk about if pressure is constant, how each one of these relationships is either shown as direct or inverse, and then lastly we're going to talk about what the relationship between pressure is and each of these three things as well. To start, let's talk about the two different types of relationships there are. When you're talking about two variables, if I increased one of them, what happens to the other? If one increases, or decreases, and the other one acts the exact same way, then the other is going to act the same way. It's going to do the same. Let me put that a little bit clearer this time. In a direct relationship, if the first variable is increased, the second variable will also increase. If the first variable, however, was decreased, then the second variable is also going to decrease. In a direct relationship, they do the same thing. However, in an inverse relationship, if one is increased or decreased, the other will do the opposite. So if I increase the first variable, if pressure was increased and it had an inverse relationship with a different variable, then the other variable is going to be decreased. They do the opposite thing. If one is increased, the second one is decreased. If the first one is decreased, the second one will be increased. That is an inverse relationship. So now let's assume that pressure is constant. And I'm going to go back to that simulation that we saw, and we're going to see these three different relationships here. 1, 2, and 3. We're going to explore and see if when pressure is increased, what happens to volume, and then we're going to determine whether it is a direct or an inverse relationship. So I'm going to pull that up right now. Here we go. So if temperature is increased, then volume will do what? And we again are assuming that pressure is constant here. So I am going to set pressure constant, and where I can still change the temperature. All right, so if temperature is increased, remember pressure is constant here, then my volume is going to increase as well. You saw that it was getting larger there. Volume will increase as well. They did the exact same thing there. So which type of relationship is that? If you said direct, you were correct. They did the exact same thing. One increased and the second increased as well. So it must be direct. Number 2, let's see if we can add different amounts of particles. Let's reset this. Let's add in 50 particles. Let's make sure that pressure is constant. Let's see if we can do that more gradually this time. So pressure is constant. Let's add in another particle. Oops, this one. All right, I've got it this time. So let's put in 50 particles. Let's go ahead and set pressure constant where we can still see what happens to temperature. What happens if we add another particle? Let's see what happens. You can see that my ice bucket just came up. It went from 300 Kelvin to 294 Kelvin. And I could keep adding these in and see that the temperature is going to keep going down. My ice bucket is still showing there. So therefore, we can see that this is a inverse relationship. If one particle is added, the temperature goes down. This is a downwards arrow, in case you can't tell. That is an inverse relationship. In the second one here, let's see what happens between volume and number of particles. Let's reset. Go ahead, open up particles. I'm going to put in 50 light ones. I'm going to make sure that I set it so that pressure is constant, but volume changes to keep it constant. I'm going to put in now, so that you can see it a little bit easier, one blue particle and see what happens. What happened to the volume there? Let's see it again. Add in another one and another. So every time I put in a blue particle, the volume is going to get bigger so that the pressure in the system stays the same. If volume is greater, then the particles must be greater as well, which is a direct relationship. Okay, so that is the relationship between temperature and volume, between the number of particles and temperature, and then how many, and then the number of particles and volume. You can see one was direct, actually two were direct, and one was inverse. Let's look at our last relationships now, and that is between pressure and temperature, pressure and volume, and then pressure and number of particles. For that, I'm going to go to the other part of the simulation. Let's put in 50 particles here. If my temperature is increased, what happens to my pressure? It is also increased. But if I go over here to laws, and I hold volume constant, let's see now what happens. Let's put in 50 particles. My temperature is increased, my pressure is still increased. So it looks like no matter what, these have a direct relationship. Direct relationship. When one goes up, the other one has to go up. Let's see what happens when pressure and volume are compared. Let's hold temperature constant. What happens to my pressure if my volume is increased? My pressure is then decreased. Let's go ahead and close up the volume. Let's make the volume smaller, and my pressure is increased. So these ones have an inverse relationship. Finally, I have to go back to the intro here to show this one. What is the relationship between pressure and number of particles? Well, if I add more particles, the pressure is going to go up. So if I held temperature constant, and I added more particles, you can see my volume is staying the same, and also my pressure is going up. We're focusing on the relationship between pressure and number of particles here. So these have a direct relationship. If I add more particles, there are going to be more things hitting the sides of the system, therefore the pressure will increase. So there's an overview of everything that we just did. Hopefully you can now see that there is a relationship between temperature, pressure, volume, and number of particles. In the next video, you are going to see kind of like a trick to easily remember the relationship between pressure, temperature, and volume. It won't show the number of particles, but I think that you can determine that if you think through that is a direct relationship between pressure and number of particles. So go check that out now.